Hi guys. Okay, I've just done the sine rule. Now I'm doing the cosine rule. So in the formula sheet, guys, there's three rules here: sine rule, cosine rule, area of triangle rule together. This is the cosine rule. Key points. Again, it works for any triangle. It doesn't have to be a right angle triangle. We use it to find a side when you have two sides and the angle between them, and use it to find an angle when you have three sides. In fact, guys, when students ask me how do I know when to use the sine rule and when to use the cosine rule, rather than learning all the four reasons, two for cosine rule, two for sine rule, I just tell them these two for cosine rule, and if it's anything else, it's the sine rule. So two sides and the angle between them, that's this. There's two sides, there's the angle between. And to find an angle, all three sides. Okay, here we go. So there's the formula: a squared equals b squared plus c squared minus 2bc cos a. Now note, guys, it is a squared here equals b squared plus c squared minus 2bc cos a. So it's always around, it's this squared equals this squared plus this squared minus 2 times this cos of this. Okay, so just follow what's going on here, but remember, I mean, you don't have to label things A, B, and C, and sometimes students get confused with the whole A, B, and C thing. I just say, remember, it's the two sides between the angle. It's this squared plus this squared minus 2 times this times cos of this. So it's always kind of everything's happening around here. So x squared equals this squared, 28 squared, plus this squared, 35 squared, minus 2 times, I'm just going to have to move this, guys, for a second, minus 2 times 28 times 35 times cos 32. Okay, I'm really going to have to move that away. Okay, I'll move that right over here. So 2 times 28 times cos 35 times cos 32 degrees. Now guys, look, you can just go straight to x here, and you sub in the you sub this into the calculator, because if that's x squared, x is going to be the square root of all that. So take out the calculator. I do the square root. Now, by the way, guys, this is sometimes something that students forget to do, is actually get the square root. They just stick with x squared, which is obviously totally wrong. So it's the square root of 28 squared plus 35 squared minus 2 times 28 times 35 times cos 32, close brackets, press enter, and I get 18.62. Let's go with 2 decimal places. 18.62. Now, does that make sense? Yeah, I think it does. That this side should be smaller than these sides. Yeah, I'm sure that's right. Okay, so that's it, guys. It's not hard once you sub the right things into the formula. Okay, let's move this guy now here. Question 2. Find an angle. Now, they give the formula like this, guys. There is an option to, if you like, rearrange this. Now, some students literally rearrange this straight away as soon as they get their exam, just in case they need to use the formula for the angle. But essentially, through like changing the subject of the formula, we can swap the a squared and the minus 2b, or the 2bc cos a, because I can add this to the left and subtract this to the right, and then divide by the 2bc. So I can actually, in one go, I can say cos a is equal to b squared plus c squared minus a squared all over 2bc. So you can start with that, or you can actually sub the numbers into the formula as you see it and rearrange after. I think I will do it I'll just sub into the normal formula, guys, and then I can show you the other way after if you want. So I'm going to say a squared. So a squared, if I'm looking for cos a squared, the little a squared, is the side opposite the angle. So that's very important. That a goes with this a. So the side opposite the angle. So I can say, right, 11 squared equals b squared plus c squared. So that's the 17 squared plus 14 squared. Then minus 2bc, so that's 2 times 17 times 14, and then it's cos theta. Then I can let's go 11 squared equals 17 squared plus 14 squared minus, now I'm just going to multiply this number out, guys, just so it's kind of clear what I'm doing. I'm going to say this is 2 times 17 times 14, which is 476. So minus 476 cos theta. So this is the same kind of rearrangement that I did up here, guys. I'm going to swap this over here. So I'm going to say 476 cos theta. I'm adding this to the other side, if you want to think of it like that. Because it's minus here, I need to add it over here. And that equals the 17 squared plus 14 squared are staying, they're not doing anything. But the 11 squared I'm going to subtract on the left, like that. Which means cos theta is equal to 17 squared plus 14 squared minus 11 squared all over 476. Now, if, just to show you guys, I won't do it fully this method, but just to show you how it would have worked, you could have gone straight to this if you rearrange the formula at the start. So you have b squared plus c squared, that's your b and your c, so 17 squared plus 14 squared, minus a squared here, that's your minus 11 squared, over 2bc, and this was 2 times 17 times 14. So you could have gone straight to this step if you're comfortable with this formula. So either way is perfectly fine. I don't mind which way you do it. So theta, once you have cosine of theta, to get theta, you have to do the inverse cos. So inverse cos, I'll do fraction 17 squared plus 14 squared minus 11 squared all over 476, close brackets, and I get 40 point, let's go with 1, 2. So that's 40.12 degrees. Okay, that's it, guys. That's the cosine rule.